Okay, thanks very much. Yeah, in case anybody's frightened, there won't be any Heideggerian stuff in today's talk. And the new book is going to be called Thinking Without the Box. And it's a kind of defence of the extended mind hypothesis. All right, so here's what I want to do today. I was asked to explore the links between artificial intelligence and this extended cognition hypothesis. And a little bit further into the talk, I'll identify two natural questions to ask about the relationship between these two things. Along the way, I also want to use this context to say something about the relationship between artificial intelligence and cognitive science, which was one of the questions that Vincent mentioned at the start of the conference too. Right, so there'll be a sort of multi-dimensional kind of view here. So first of all, what's this hypothesis? So here's a kind of complicated definition, or statement rather, of the key claim. And I'll just read it out, and it will sound complicated, and then I'll pause on various bits of it to explain what it means. So according to the hypothesis of extended cognition, there are actual, in this world, cases of intelligent thought and action in which the thinking and thoughts involved, more precisely the material vehicles that realise the thinking and thoughts, are spatially distributed over brain, body and world in such a way that the external, by which I mean beyond the skin factors concerned, are rightly accorded cognitive status. So let me just pause to comment on this definition, this statement of the claim. First of all, just want to make it clear that I think the hypothesis would be completely uninteresting in a way if it didn't apply to actual cases. All right, we can argue about science fiction cases and all kinds of things, Doctor Who examples and so on. But in the end, even if the arguments go via various kind of science fiction cases, the result has to be that there are plausible cases of extended cognition in this world. And this qualification that turns to the material vehicles is important. So the claim here, I often put this by thinking about something that I call the Flack-Hathaway problem. Flack and Hathaway aren't philosophers, they were soul singers, and they had a great single out in the 70s, I think, called Where is the Love? Now, when Flack and Hathaway asked that question, they didn't expect spatial coordinates as an answer. All right? But if one changes, and of course there might be legitimate questions one might ask about mental or cognitive states and processes, for which a kind of spatial answer wouldn't be appropriate. Right? A location answer wouldn't be appropriate. But we can ask, and we can ask this via psychology and neuroscience and so on, where are the physical processes in the world in which these psychological or cognitive states and processes are realised? So, and that's this notion of a vehicle, which some of you outside of philosophy of cognitive science may not be too familiar with. So the thing that carries the cognition, if you like. And just two other things. First is that qualification by external, I mean beyond the skin. There's an annoying intermediate position. You might think the internalist position, the kind of traditional alternative here, is that cognition happens solely in the brain. And the extended view suggests that sometimes cognition happens in brain, body and world. A system, an integrated system that's distributed spatially over brain, body and environment. There's, of course, an intermediate position which says that cognition is distributed over the brain and various non-neural parts of the body, but never gets further than the skin. And I think you can treat that as a kind of less extreme version of the extended mind view, or a kind of more radical kind of internalism. I don't mind. That's a kind of intermediate view. But the view I want to consider here is one that, as it were, goes all the way out, all right, where external factors could be smartphones, could be laptops, could be diaries, doesn't matter. Certain external factors literally count as part of the realising base of the cognitive process. And this last phrase, rightly accorded cognitive status, I don't want to make too much of a fuss about that at this stage. Right at the end of the talk I'll say something more about that. But the intuitive idea is that according to the extended cognition view, sometimes external factors, smartphones, diaries, whatever, have the same status with respect to cognition as the brain has in standard thinking about these things. Now, the canonical presentation of this view is Andy Clark and Dave Chalmers' 1998 paper, The Extended Mind. And that's the first place where most people start. Actually, as always with these things, there are precursors of the view. Some stuff that Dan Dennett wrote about what happens when you take away the environment of people with Alzheimer's disease back in Consciousness Explained, I think, is very much a precursor of this kind of view. So it didn't come from nowhere. All right. But that's the kind of canonical presentation. Later on, I'll argue that Andy Clark's current favourite argument for the extended mind won't work, but that comes later. All right, so here's something that I'm now really nervous about from given Martin's talk yesterday. So what I want to say here is that I'm going to appeal to a kind of naive notion of multiple realisability, and I know that this concept has come under stress in some recent philosophy, but I'm just going to run with it for today. It looks like the extended cognition view is committed, and at least in the version I want to hold of it, is committed to this idea of the multiple realisability of the cognitive. And here's the thought behind that. It's a very straightforward thought. Sometimes we can do, say, mathematical thinking solely in our heads, right? I can solve a mathematical problem, if you like, solely using my organic resources, my brain. On Monday, I might do it that way. On Wednesday, I might solve the very same problem, or a related difficult problem, using a system that involves pen and paper manipulations of material symbols. And the idea is that these two systems, these two processes, in some sense are functionally equivalent, in a sense that would need to be made specific, but they're realised in different physical systems, right? One that's wholly organic and one that involves the organic brain, movements of the organic body, and the manipulation of bits of the environment. Literally the cognition spreads out and is partly realised by the material symbols on the page. Or it may be by a process in your smartphone or something like that. So it needs, I think, extended cognition, as I understand it, needs something like this principle. Maybe something like the notion of organisational invariance that we heard about yesterday would do the same job. There's a way of getting this result of multiple realisability that's very popular in philosophy of cognitive science, and that's good old-fashioned functionalism. According to the functionalist, what matters when one's endeavouring to identify the specific contribution of a state or process qua cognitive is not the material constitution of that state, what it's made of, but rather the functional role it plays in generating the phenomena of interest. By intervening causally between systemic inputs, systemic outputs, and other functionally identified intrasystemic states and processes. All right, so very natural kind of functionalism about the mind. Now, in the history of philosophy, functionalism was interpreted so as to secure a kind of in-the-head multiple realisability. In philosophy of mind, we went, imagine that mental states were identical with neural states. All right, if you didn't have the neural state, you couldn't have the mental state. And then we got very, very excited about what we would say about Martians who had very different physical brains. And we said, OK, what we need to do is move to a kind of functionalist hypothesis so that the Martian brain can produce states like pain and belief just the same as the human brain, even if it's made of very different stuff, or indeed silicon, if you want to do it in an artificial context. Now, the interesting thing is that functionalism was always interpreted as talking about what about the brains of Martians. But of course, that in-the-head bit is strictly an add-on to the view. All functionalism really says is that there's some system here in which certain functional contributions are made, and that system is the cognitive system. So it allows, in principle, that the borders of the cognitive system can fall beyond the sensory-motor interface of the organic body. So the possibility of extended cognition, the mere possibility of it, is established by being a functionalist. That doesn't tell you that there are any states, any systems in the world that actually realise extended cognition. It just says it's a philosophical possibility. And Andy Clark originally, and I picked up with this term, we called this extended functionalism. I'm not overly keen on the term because it suggests that we're extending the theory of functionalism. I think we're just unpacking the theory of functionalism. But actually it's become the standard term. So when people say that we're mad, they say the extended functionalists are mad, so I'll sign up with that. Right. Now here's something just to note for the outset. This is getting onto the relationship between this view and AI. Functionalism has traditionally been the house philosophy of artificial intelligence, right? There's no doubt about that. Okay, and we talk about the functional profiles of the systems that we build and so on. So I just note that for the moment. Two questions for today then. How might research in artificial intelligence bear on the truth or otherwise of the extended cognition hypothesis? Question 1. Question 2, would the adoption of the extended cognition hypothesis by everybody in this room who does actual AI programming, would that enable you to do your AI better? Right? 2 questions. I'm going to spend nearly the whole talk on the first question because having done that, an answer to the second question falls out. Right, so that's where I'm going to go today for the next sort of 30 minutes or so. All right, so I'm going to talk about 3 different ways really quickly in which you might think that some research in artificial intelligence already, as it were, shows that the extended cognition hypothesis must be true. Right, okay? In the end, I'm going to suggest none of this work really does enough. But let's start by just, as it were, unpacking a kind of intuitive picture. So let's just go back a few years, back to the early 1990s when Rob Brooks and other people around the world started really focusing on building robots of a certain kind to understand intelligent processes. This will be very familiar to everybody in the room, so I'll do it quickly. There was this strategy that came out of the situated robotics or behaviour-based robotics community, which was that what we should do to study intelligence is build complete robots that are capable of integrating perception and action in real time, in real-world environments as much as possible, so as to generate fluid adaptive behaviour. And part of the kind of program that got attached to that basic thought was the idea that detailed inner world models, whilst they might be important somewhere along the line, detailed inner world models get in the way when it comes to performing fluid perception and action cycles. And the idea, which some of you will have disagree with and some of you will agree with, I don't mind whether you're on board or not for this, this is just to illustrate how extended cognition might fall out in theory from this kind of stuff. The idea was that detailed inner world models are difficult, computationally expensive to keep up to date in a changing dynamic world. And so detailed inner world models got sidelined in favour of architectures that produced adaptive behaviour by regularly sensing the environment in order to guide actions. So rather than build a world model and let that guide action, world models difficult to keep up to date and so on, just keep looking at the world and let the world guide your actions in a kind of ongoing close coupling. This is famously the phrase that Rob Brooks coined, although Bert Dreyfus claims that he said it first and Brooks stole it from him, but we'll let him fight that out. Rob Brooks described this as using the world as its own best model, or its own model. And also this idea gets called situatedness. So we have a picture here where inner mechanisms and non-neural bodily factors and environmental elements are supposed to, as it were, work together as equal partners in some sense in the behaviour generating process. For time, I won't go through a kind of particular example of that because I think the general idea is clear that in these kind of architectures, rather than building a world model, there's a dependence on using the environment. So the environment becomes this important causal factor in the ongoing loop that produces the behaviour. Classically, the simplest example would be, a wall-following robot. You could build a model of the wall and then plan a path to go along it, or you could just build a robot that has a tendency to go towards the left, but bounce off the wall each time, when it gets close to it, as it were. And it would be a perfectly good wall-following robot, and you couldn't take the wall out of the story without the functionality collapsing. So yeah, but that's kind of interesting. So it looks like the environment's playing a really important role in the maintenance of the intelligent behaviour, and so you might think that's a move in the direction of extended cognition. Here's a more sort of explicit claim that's been made recently in work in artificial intelligence by Tom Froese and colleagues in a paper called The Dynamically Extended Mind, a Minimal Modelling Case Study. And Froese and co in this paper build a model of an embodied agent. And I'm not going to go into the details of the experiment. They don't matter. What matters is the structure of the claim that Froese et al. Made. So I want to agree with this. They show something really interesting. Okay, so with the robot is driven around by a dynamic recurrent neural network. And what they show is that this artificial nervous system, this dynamic recurrent neural network, changes its form as a dynamical system as a result of being coupled with the environment. So the claim is this, and then I'll explain it, that this network goes through a change of identity from one type of system to another. And that's only explainable as an emergent outcome of non-linear coupling between the network, the body, and the environment. Right, that's the claim. So what happens here is they start out with a continuous time recurrent neural network, and pre-coupling, it can be understood as a one-dimensional dynamical system. Post-coupling with the environment, with the body and the environment, it exhibits properties such as oscillatory and chaotic dynamics, which establish, I think, without doubt, that it's been transformed into a higher dimensional dynamical system, because you won't get oscillatory dynamics in anything less than a 2D system, and you won't get chaotic dynamics in anything less than a 3D system. So these look like that's a perfectly good analysis of what goes on here. And this establishes, according to Froese and colleagues, that the phase space of the agent's network must be explained in terms of the whole brain-body environment system. Sorry, that's a very strange, that quote there got messed up in the cutting and pasting, but never mind. Whole brain-body environment system. So you explain the cognition by appeal to this unified brain-body environment system. Again, you might think, sounds like extended cognition, surely. I'll come back to these examples a bit later. Another route you might think is what I call, with due nervousness, the distributed cyborg route. These, so far, I've talked about a couple of AI examples where it looks like understanding the system or building the system already imports or establishes some kind of appeal to an extended cognitive process. However, you might think another way you might go to see the relevance of AI to extended cognition is to think that, is to kind of say a slightly different view. One thinks that there are these organic systems, us, right, and we couple with technology in all kinds of complex and interesting ways, and we can get the technology to be more and more sophisticated in its contribution to our thinking, all right, by putting smarter and smarter AI algorithms and processes into those artifacts. So, just make your smartphone smarter and smarter and smarter by putting in loads of fancy AI stuff, and it looks like that's going to do, a lot more in terms of supporting your thinking, your memorising, and so on. I don't know if anybody else is like this, but of course, I don't store phone numbers in my organic brain anymore. I really did used to, but I don't anymore. I mean, the phone does that memory job for me. And imagine it did a lot more. Imagine you had in your phone various bits of neural networks that did bits of default reasoning, such that, when you decided to do things, you kind of offloaded that intelligence onto your phone. In fact, I'm sure that's already happening all over the place. So it looks like there's some kind of contribution here. You might say, well, artificial intelligence can make the technology smarter and smarter, and surely that makes it look a lot more like it's doing some of the cognitive work in these organic technological hybrids. Actually, I don't think this is essential to the case for extended cognition. There's something to be said here, and in another talk I might go into this more. But in fact, most of the canonical examples of extended cognition were run off the back of kind of thought experiment cases where the external technology was nothing more sophisticated than a notebook where you wrote things down. Right, and whenever you wanted to, a classic example is a navigation task. You want to get to use the classic example, the Museum of Modern Art. One person might store that information in their organic brain. Someone who perhaps has some kind of imaginary cognitive deficit, such as they can't store information like that in their brain, might store the information in their notebook. Over time, the notebook gets brought into their cognitive processing in such a natural, fluid, and automatic way that information supports the navigation behaviour in the way that the organic brain of someone else might. Right, it's that kind of story. So these kind of technologies are hardly sophisticated, right? It's just notes on paper. So maybe the sophistication of the technology in the environment isn't the key thing. So I just note that perhaps that argument isn't the way to go. I should note at this point that after Ted Berger's fantastic talk last night, you might think we're sort of problem solved, right? Okay, here we have, a piece of technology that provides the route for laying down memories in the feeding, in the kind of dynamics of the brain, and that somehow that bit of technology clearly counts as a kind of add-on to the organic part of the system here, and that surely that there must be that does a cognitive task, and thus is part of we have a kind of extended cognitive system here. If you think that's right, if your intuition's already going that direction, having heard Ted's material, then some of the stuff I'll say in a moment will be designed to cast a little bit of doubt on whether that's the obvious conclusion. All right? And the last bit of the talk will be telling you why it was the right conclusion all along. You just didn't have an argument for it. Okay, right. Okay, so So far all I've done, right, I mean I haven't done anything clever at all yet. All I've done is told you what the extended cognition hypothesis is in a kind of philosophical articulation of it, and I've tried to say that there's work going on in artificial intelligence, giving you a couple of examples, where it looks like environmental factors are brought into the understanding of the underlying causal system, such that it would be natural to draw a kind of extended cognition example. So, in the case of the Brooks robots, you might say something like this: in a standard internalist cognitive science architecture, the coordination of different behaviours would no doubt be controlled by some inner executive or some kind of inner arbitration process. But one might say in the pure versions of the Brooks subsumption architecture, what coordinates the behaviour is the world. Right, the world plays the coordinating role. Different processes index their behaviour off the state of the world, right, rather than an internal model or something like that. So you might think the orchestration task that we standardly place inside the brain is now being run through the environment. Extreme cases may be, in a sense, controlled by the unfolding of the environment. Purely reactive cases. In the Frusi material, we get more the idea that somehow you can't understand the system unless you factor in the whole brain-body environment causal process, something like that. Okay, but not so fast, right? You know, so the important point here is, and this gets a lot. I mean, if you're currently involved in this debate in philosophy of cognitive science, then the distinction between the extended view and the view I'm just about to bring on the table is where the action is, if you like. It's telling the difference between these two cases that matters. But what I guess is just one of those sociological dynamic things is that outside of that narrow, perhaps, you know, slightly anal philosophical debate, as some people might think of it, there's just a running together of many different views that to us from the inside, as it were, look as if they're saying different things. So people often write in papers, in not only in AI but in bits of psychology and in other areas where the extended mind has started to have a kind of effect. They'll say, yes, I'm an extended stroke embedded stroke embodied stroke situated stroke interactionist theorist, right? As if these all mean the same thing. Embarrassingly, a few years ago, I wrote a paper where I said, you know, only someone with too much time on their hands would worry about pulling these positions apart. And since then, I don't think I've had too much time on my hands, but that's all I've really done. Right? So anyway, but I want to now make a really big fuss, right? And I hope in a way that doesn't just sound like philosophical niceties. A really big fuss. Well, it shouldn't anyway, if the argument goes through. A really big fuss about distinguishing the extended view from a view called the embedded view. Okay, so here's a statement of the hypothesis of embedded cognition. Again, it's a bit complicated. I'll read it out, and then I'll try and explain its import. So according to the hypothesis of embedded cognition, the distinctive adaptive richness and flexibility of intelligent thought and action is regularly, and perhaps sometimes necessarily, causally dependent on non-neural bodily structures and or movements and or, and this is the key bit, on the bodily exploitation of environmental props or scaffolds. And there's a key distinction here. I'll give an example in a moment. But the key distinction here is between what you might think of as merely causal dependence and something that you might call constitutive dependence. So here's an example, trivial example, doing mathematical reasoning. Okay, so in the mathematical reasoning case, let's imagine you're in a situation where you couldn't do the sum in your head. It's too complicated. And you're old school, so you get your pen and paper out, all right, and you start fiddling with symbols on the bit of paper, right, rather than just using a bit of techno kit. Now, for the extended theorist, the brain and the bodily movements and the material symbols on the page, that's where cognition is, literally. I mean, literally. I mean, to put it in a kind of crude neon lights kind of programmatic way, ripping away the paper at that point would be equivalent to ripping away a bit of the mathematician's brain, right? Because they're all part of the cognitive process. The embedded theorist doesn't say that. The embedded theorist sees exactly the same behaviour and says, that's really interesting, right? In this case, the cognition is much simpler than actually going through the complex mathematical procedures, right? The cognition is a matter of, I don't know, pattern matching and a bit of kind of serial organisation of action. And what happens in this case is you can get a system that, you know, doesn't do much more than pattern completion and moving a few muscles around to produce a mathematical result, by allowing a system like a cognitive system like that to lock itself in a closely coupled way with bodily movements and with environmental structure. So the scaffolding part here, the environmental scaffolding, which in both cases helps to get the mathematical result. Right? In one case, it's literally thought to be part of the cognition, literally has cognitive status. In the other case, we say, no, cognition is a lot simpler in this case, right? It's just pattern matching and a bit of other stuff. But to get the mathematical result, you need to couple a bit of cognition like that with these external elements. So the cognition remains internal, even though the final result depends, perhaps in necessary ways, on the exploitation of environmental structure. Now, these clearly are different views, as one might say, with one's, traditional philosophical or metaphysically, right? Because mind or cognition is in a different place, right? In one case, it's throughout the whole system. In the other case, it's only in the brain. And it's different in the two cases in what you think cognition is. And that will come out a bit later. And the way to put this philosophically is to say that in the embedded case, there's a causal dependence of the result, anyway, of the cognitive result on the use of environmental scaffolding. In the extended case, there's a constitutive dependence. It's literally part of the cognitive process. Now, some of you in the room's immediate reaction, I hope, some of you are much more, as it were, at the practical coalface of AI, your immediate response to that might be, I don't care. Right? If that's your response, I'm going to give you reasons for thinking that's not a bad response at all. Right, in the next few minutes, and then I'm going to try and convince you that it was the wrong response. Okay, so the shape of the debate. So the embedded theorist seeks to register the important, perhaps sometimes necessary, causal contribution made by wider bodily and environmental factors to many cognitive outcomes. That said, the embedded position is that the actual thinking in evidence in such cases remains a purely brain-bound phenomenon. The actual thinking, the actual cognition. Although one that's given a kind of performance or behavioural boost by its surrounding ecology, including the technology. But here's the key point, right? Here's the key point that I want to push. Philosophers of science often talk about conditions for theory change. And when we do that, there's a kind of principle we think is good scientific reasoning. If you've got two hypotheses that perfectly predict the data, right, or by some other canon of explanation, explain the observed data, and one of them requires a massive revision to other things that we think, to the conceptual foundations perhaps, or methodological prescripts of a field, and one doesn't require any such rewriting of stuff, then go with the more conservative view until you've got good reasons not to. And that's thought to be a pretty good principle in science. So in this case, you might say this. Look, cognitive science and artificial intelligence that's focused on, as it were, internal or brain-bound processes as the seat of cognition, it's done pretty well, right, overall. Cognitive psychology is a very successful discipline. So we don't want to throw all that internalism that drives standard thinking. If we don't have to throw that out, don't. Keep the cognition internal, but see that sometimes, quite realistically, that the cognition is locked into these closely coupled loops with the body and the environment in such a way that many of the outcomes, perhaps most of the outcomes we achieve as cognitive systems depend on our involvement in, our coupling with a surrounding technological ecology. So the embedded cognition view is the kind of default view, right, that has to be shifted. If you've got these two views and they're on a par with respect to predicting the data, predicting the behaviour, and you might put this in an AI sense by saying, if the system is going to be built in a sense the same way in both cases, it's just how I label my variables. I'll label my variables in the conservative way and then not get into so many difficult arguments about the weird idea of cognition being in the environment in part. And just to make this very clear, so Andy Clark's favourite argument at the moment for the extended mind is what he calls an argument from cognitive self-stimulation. And cognitive self-stimulation is a phenomenon that occurs all the time, I'm sure, and it occurs like this. It occurs when you've got neural systems that are causally responsible for producing certain bodily movements and beyond the skin structures, which are then recycled as inputs to those neural systems. So gestures, if you think just an embodied case, gestures would be a great case, right? I'm waving my arms around all over the place now. Psychologists tell us, there's very robust evidence, that your thinking gets worse if you're not allowed to gesture, right? Gesturing seems to be we produce the gestures and somehow that feeds back onto our cognitive system, if you think of it in an internalist way, and gives it a kind of boost. But you can do it with other ways. You could produce environmental structures that then feed back onto your cognitive system. Again, to take an example from Dan, I think it was originally from Dan, it might be the case that a certain pattern of rain on your window makes you think better, just makes your cognitive system think better. I think it was, as Dan's example of, imagine therefore you could produce the same kind of rhythm, kind of spitting onto a metal plate that's in front of you, as it were, and that structure then feeds back into your brain and makes your brain work better, right? And, you can think that that's you producing structures that then somehow push your cognition along. So if this kind of feedback process produces kind of various problem-solving benefits, then you might think this is a case of cognitive self-stimulation. Now, Andy argues as follows. He says, this is a quote from Supersizing the Mind, sometimes all coupling between brain, body, environment, is provide a channel allowing externally originating inputs to drive cognitive processing along. But in a wide range of the most interesting cases, there's a crucially important complication. These are the cases where we confront a recognisably cognitive process running in some agent that creates outputs, such as speech, gesture, expressive movements, written words, and so on, that, recycled as inputs, drive the cognitive process along. Here's the argument. In such cases, any intuitive ban on counting inputs as parts of mechanisms seems wrong. So and Andy explicitly draws the extended cognition conclusion from this argument. So the idea here, and some of you might have already spotted where the problem is here. The idea here is that in cases where we, as it were, produce these outputs that then get recycled as inputs, and that loop drives the cognition along, we don't have any principled reason for taking those inputs that we construct after all and treating them as non-cognitive. They're just an integrated part of the thinking process. The problem here is that Andy doesn't actually draw that conclusion in the quote, right? What he says is that any intuitive ban on counting inputs as parts of mechanisms seems wrong. And of course, everybody's going to agree with that, right? At least the embedded theorist. Rabid internalist might not, but the embedded theorist will agree with that, right? Because that argument doesn't say enough. Because embedded and extended theorists both agree that self-generated inputs that support these self-stimulating loops are parts of well-defined mechanisms that push the thinking along, right? But for the embedded theorist, the properly cognitive part of this process is going to be the brain, right? It's a subsystem in a bigger mechanism that drives the thinking along. So the cognitive part is the brain within an extended system, but the extended system itself doesn't itself count as a cognitive system. It's an integrated, powerful, behaviour-producing system that's a coupling between a cognitive component, the brain, and an embodied component and external structure. So for the embedded theorist, the properly cognitive mechanisms are subsystems of larger performance-enhancing loops, where the latter are not cognitive mechanisms in their own right, even though they contain cognitive mechanisms. And the idea here is that in a self-stimulating loop, you can do full justice to the idea of cognitive self-stimulation as an embedded theorist by just adopting that view. Right? So again, there doesn't seem to be, and it's interesting that, as I say, Andy's quote doesn't say counting inputs as parts of cognitive mechanisms seems wrong, just says mechanisms. The embedded theorist agrees with that. There's definitely a well-integrated mechanism here. It's just that only one part of it is cognitive. So there's a moral here that I think we can draw. Our reflections on cognitive self-stimulation indicate there may be extended systems that are not themselves cognitive systems, although they may contain embedded cognitive systems. And it seems pretty clear that in the case of the Brooks robots, that's for instance, a perfectly reasonable conclusion to draw, right? Of course, it's interesting. The environment is playing this interesting role in coordinating the various activities in the subsumption architectures, but the embedded theorist will just say, well, that's fine, okay? That's interesting. Just shows you cognition is this group of very sufficient internal mechanisms that only in the pure case communicate with each other via the environment. Now, the Froese case, I think, is a bit more complicated, right? But actually the same conclusion should be drawn. There's actually a fuller version of an argument here that I can only, I think, have time to do the first half of, because I want to get to the other part of the talk. So what Froese and co argue is that the non-isolated network, by which they mean the network that's coupled to the body and the environment of this little agent, is determined by its input, this is a quote, albeit mediated by its internal activity, while this input is determined by its motor output, albeit mediated by bodily and environmental activity. Now, I'd have to go into more detail to really substantiate this claim, but trust me, if you understand that quote the right way, it's an example of cognitive self-stimulation. And we have reason to believe, from the reflections on the Clark case, that this kind of claim, the supposed observation that there's cognitive self-stimulation here that's supposed to drive us to an extended cognition result, doesn't carry us that far because of the principles we extracted from the Clark case. So I think it's clear that Froese and so overstep the mark, right? They've clearly given us an example of an embedded system, but it's not clear that it's an example of an extended system. How much have I got? Just to check. 10 minutes. Okay, in that case, let me say something very briefly what I think Tom Froese would say to me at this point, right, if he were in the room. I can hear him ringing in my ears. I think what Froese and co would say is that what I'm missing out here is the fact that the coupling between brain-body environment in their agential case is non-linear. And when you get non-linear coupling, you produce something that they call, following Tony Chimero, a non-decomposable system. All right? So what's that? I'm going to take it that you know what non-linear coupling is. A non-decomposable system is a system, quote from Chimero, that cannot be modelled even approximately as a set of separate parts. Or equivalently, a system whose behaviour can be characterised only using collective variables and or order parameters that summarise the behaviour of the system's components. So I think this is very tricky, and I don't have time to go into this in full detail, but the idea is that where you get non-linear coupling between brain, body and environment, it produces a non-decomposable system because of the non-linearity of the coupling. If it's a non-decomposable system, then you might say, well, you know, the cognition here is the whole brain-body environment system. We can't decompose it into the brain bit that does the cognition and the other bits that don't. That's the intuition. That's the intuition. Well, there's an old example that used to run around the philosophy of cognitive science for a few years, thanks to Tim van Gelder, which I'm going to use for a very different purpose here, right? So I ought to have called this learning from the Watt governor again. James Watt didn't know what he was doing for cognitive science when he came up with this example. So in the Watt governor, right, we know how the Watt governor works. It's a distributed mechanism for controlling engine speed. And if we understand this in dynamical systems terms, there's an equation that describes the engine speed and an equation that describes the change in arm angle of the governor. Right, so you know how these things work. As the engine speed increases, the arm angle of the governor increases, but due to forces at work, that tends to dampen the speed again, and so on, and so in the other direction. Now, there's no doubt the maths tells us these are non-linearly coupled systems, right? And Chimero and co agree with that. Any change in the arm angle changes the entire dynamics of the system that describes the speed of the engine. Any change in the speed of the engine changes the entire dynamics of the system that describes the change in the arm angle. That's non-linear coupling. So for Chimero, Froese and company, this is a non-decomposable system because non-linearity is sufficient for non-decomposability. But look, whatever non-decomposability means, I'm not really quite clear what it means. There's no doubt that in the maths of the governor system, we have a governor engine system still features a kind of engine side variable parameter, engine speed, and a governor side variable or parameter, depending on which angle you're looking at, of arm angle, right? So even if this produces a non-decomposable system, whatever that means, it looks like we can talk about variables that are on one side or the other of a divide. I mean, if you transpose that into the cognitive case, what you've got is an agent side variable and an environment side variable, right? One might think it ought to be possible to, at least it doesn't look like non-decomposability is straightforwardly, if it means we can't ever make a division within the system, then that's not established by non-linearity, because here we have a case of a non-linear nonlinear coupling where we can still, indeed we have to in the maths, we don't have to, but it's a legitimate explanatory procedure to think about the coupling between two variables, stroke parameters, one of which is on one side of a divide and one of which is on the other. Transpose that to the cognitive case, well, you know, there'll be agent side variables which are cognitive and environment side variables which the embedded theorist will say aren't. So nonlinear coupling may produce a non-decomposable agent environment system, but it's not yet settled which elements within that extended system are cognitive in character. I think this is an open argument. I think there may be spins and things to go on that we haven't got to yet, but I don't yet see the force of this argument in the way that Froese and others do. Because the embedded theorist will just play the embedded as default card yet again. Just say, yeah, there's an internal bit here, that's the cognitive bit. Nonlinear coupling, very, very interesting. Need to think about it, but it doesn't produce extended systems. Produces extended systems, doesn't produce extended cognitive systems. Of course, the behaviour of the neural network in the Froese case will have to be understood in terms of the way it's produced by that behaviour is produced by the dynamics of the fully coupled system. That's right. But that's okay. That just says that what the internal bit does can't be understood apart from its interactions with the rest of the system. We knew that already, right? Nonlinear coupling just makes that more complicated. So here's my intermediate conclusion before I get to the very last bit. From a purely AI engineering perspective, you might say, a perfectly healthy conservatism regarding the conditions for theory change in science would favour an embedded view over an extended view. So don't relabel your variables, right? Same causal systems, right? Don't relabel your variables. That will be the conclusion. So on these grounds, AI, at least as in examples I've given, can't directly show the extended cognition view to be true. It can show the embedded view is a good view, right? Because it can show how you can build these systems that require all this environmental scaffolding to get the job done, or at least that's an efficient or a powerful way to get the job done. If all these systems like Brooksian robots and Froese stuff and so on fail dismally, right, to produce any interesting behaviour, that would be evidence that the extended view is false. But it would also be evidence that the embedded view is false, right? So again, you don't get the distinction. Okay, but here then for the last 3 or 4 minutes, hopefully, so there's some time for questions, I just want to say how this might go a bit differently. This will be fast. So, I think AI nevertheless has a really important role to play, and that's because it strikes me that the way to try and establish the extended cognition view requires a move in the argument that I haven't yet mentioned. And this is what some of us in the debate, both critics and fans of the extended mind, call the mark of the cognitive. I could give a whole talk on this, I can only just walk you through the key moves. The idea here is that we give a scientifically informed account of what it is for an element to be part of a cognitive system, one that's independent of where the candidate element happens to be spatially located. So it won't be a good thing to say here is that all the brain bits, they're the cognitive bits, right? Because that already begs the question against the extended view. You have to give an account of what cognition is where it's neutral in a sense of where it will be located. Go back to that formulation of functionalism I gave you at the start, right? Where I suggested the internalism was a sort of add-on. And with this idea in view, I think we can see a good reason for seeing AI as an important role to play in this debate, and moreover for adopting the extended view. And this is a question of where you look for your mark of the cognitive, right? So if we extract our mark of the cognitive from human cognitive psychology, say that's how you said it. So yeah, right, great idea. So where do we get our mark of the cognitive from? Where do we get our account of what cognition is? Well, let's go and look at human psychology. Right? Very successful discipline. Of course, there's going to be a tendency here, and I can't put it any stronger than that, but a tendency to beg the question against extended cognition in the following way. If you look at human memory, for instance, it's got all kinds of strange foibles, right? So if I give you a list of items to be learned, it's a completely robust result that you will learn the items at the start and the end of the list better than the stuff in the middle, right? Primacy and recency effects, all kinds of interference effects that human memory has. Now imagine you've got a trivial version of extended cognitive system where all that information, that list is stored in a notebook that you then apply to. No reason at all to think that system will have primacy and recency effects, right? You can see the stuff in the middle of the list just as well as the stuff at the beginning or the end. So the extended system, if that's what it is, the extended memory system, won't have primacy and recency effects in the way that human organic memory does. So, someone might say, if we take human organic memory to fix our mark of the cognitive, then there's a functional inequivalence here, because the extended system doesn't have primacy and recency effects, so it doesn't count as cognitive. Well, This is not a great argument. For a start, it violates the requirement, I think, about not being chauvinistic in your mark of the cognitive with respect to the internalism or externalism positions. But moreover, you know, imagine someone came along who, as a matter of fact, their organic memory didn't have primacy and recency effects. You're not going to be shoved out the door of the psychology lab, right? Well, you haven't got memory, we're not studying you. Right? So what that shows, I think, is that psychologists themselves realise that some features that they study are not essential marks of the phenomena, they're just accidental features of human cognition. So we'd need some other account of memory. Well, where are you going to look for these kind of generic accounts of memory, say, that don't focus too heavily on the foibles and accidental characteristics of purely biological cognition? And I think one way to go, I won't go through these intermediate stages, yeah, maybe just a quick minute. One way to do it, I think, was to see that artificial intelligence, at least in a kind of classic way, was thought of as the kind of science of intelligence in general. Here's a quote from Maggie Bowden. She says, "The goal of AI is to provide a systematic theory that can explain and perhaps enable us to replicate both the general categories of intentionality and the diverse psychological capacities grounded in them. It must encompass not only the psychology of terrestrial creatures that have primacy and recency effects, but the entire range of possible minds, including those that don't. It must tell us whether intelligence can be embodied only in systems whose basic architecture is brain-like, or whether it can be implemented in some other manner." Right? So artificial intelligence had this very central role in AI, I think, in traditional conceptions. AI had a central place in cognitive science under traditional conceptions. And this has been destabilised a bit by the advent of the march of fMRI scanning. But nevertheless, you know, one might still hold this is a good way to think, at least in this debate. So I think you could think that work in AI might enable us to focus on generic capacities that are important to cognition without getting hung up on the particular concrete profile of human cognition. Look for cognition, as it were, in the most general sense. So just a quick example of that to finish. Bill Bechtel's done some great work, I think, over the years, showing that cognitive achievements like mathematical reasoning, natural language processing and so on can be the result of sensory-mediated interactions between internal neural connections networks and suites of external symbols. And the idea here is that you take a phenomenon like systematicity, which is just the idea that you don't find systems empirically that can think something like John loves Mary but can't think Mary loves John. What's the explanation for that? Well, drawing on a kind of parallel with language, some people have argued, Fodor and Polish in particular, that you can explain this systematicity by thinking of the human cognitive system as organised like a language, right? So it has atomic symbols, concepts perhaps, that are put together according to structure-sensitive rules, like the rules of a grammar, right, to perform complex molecular representations. If you believe systematicity is necessary for thought, you may not, but you might think that, okay, some people do. If you thought that were true, and you thought the best explanation of that was a kind of classical compositional syntax and semantics, right, which is something like a physical symbol system hypothesis from Newell and Simon, then you've got an interesting case here, right? Because what Bechtel does is this. He says, take your internal neural network, connect it up with external symbols, which have combinatorial syntax and semantics in their system, and you get systematic behaviour. Bechtel's an embedded theorist. What he says is, that's interesting, right? We get systematic behaviour by coupling a neural network, which doesn't have any of this intrinsic systematicity, and coupling it to a symbol system that provides the systematicity. Bechtel says, that's interesting, cognition can be as simple as pattern completion, but we get systematic behaviour because it couples itself with these external symbol systems, just like the mathematician and the mathematical symbols. So for Bechtel, who's an embedded theorist, this shows cognition is rather different in these cases than we might have thought. It's just pattern completion when we used to think, Fodor used to think, it was combinatorial syntax and semantics. But if you hung on to the intuition that systematicity was a mark of the cognitive, right, look what happens at this point. You say, yes, no, systematicity is the mark of the cognitive, right, in these cases. Where's the system that underlies the systematicity, right? It's the coupled network external symbol system, the complete system. The systematicity is a function of that complete system. So if systematicity is a mark of the cognitive system is the system that's distributed over brain, body and world in these cases. The inner neural networks, the bodily movements and the external symbol systems. So the Bechtel style network plus symbol system architecture is an instantiation of what I call an extended physical symbol system. And if we adopt that as a mark of the cognitive, then we get the extended mind result. That's the way to go. So here's the last slide. So how might research on AI bear on the truth or otherwise of extended cognition? Well, although AI can't directly show extended cognition to be true, it can make a crucial indirect contribution to the issue by helping us to articulate a mark of the cognitive that isn't so focused on the accidental features of human cognition. Would the adoption of extended cognition enable us to do AI better? Well, an answer to this question now suggests itself. If a successful case for extended cognition can't be built using the strategy I just suggested, going via the mark of the cognitive, if that fails, right, if that argument's poor, and some people think it is, then the only thing that extended cognition will give the AI researcher is a kind of heuristic prop, right? Because the AI researcher might go, if I believe in extended cognition, at the very least, I'm not really likely to downplay the role of the environment in a way that if I don't think of it as cognitive, I might. But it's no more than a heuristic, because when the push comes to the shove, the embedded position is always available. And it will have exactly the same causal structure. The two systems, the embedded system, the extended system, will have exactly the same causal structure. Understood at that kind of raw causal way. Just label your variables differently. So the extended cognition view becomes, on this view, nothing more than a kind of heuristic prop. Now that can be important, right? But the embedded AI researcher who's already recognises the intimate causal dependence of cognition on environmental scaffolding doesn't need that prop. So everything here, I think, hangs on the mark of the cognitive. But the good news for AI, I think, if you wanted to contribute to this debate, is that AI has a crucial role to play in helping us to articulate that mark of the cognitive that I think in time will show us that the extended cognition hypothesis is true. Thank you.